So in this video, we're going to look about trigonometric functions. So far what we looked at different kinds of angles. We defined an angle, we looked at coterminal angles, we looked at angles in standard position, acute, obtuse, and right angles. And we also looked at other kinds of measures. So we looked at how to measure angles in radians and degrees. We also looked at how to measure angles in degrees, minutes, and seconds, and how to convert minutes and seconds into degrees and the other way around. So what we're going to do in this video is we're going to now start. We have enough background to sort of define our 6 basic trigonometric functions. So let's go ahead and define our 6 trigonometric functions. So let theta be a central angle in standard position that intercepts the unit circle. Okay, so I'm going to draw that here. We have our unit circle. Okay, and I have some angle theta, and it's in standard position, which means my initial side is on the positive x-axis, the vertex is at the origin, and then this is the terminal side. Okay, so let's call this point P, X, Y. Okay, and this is my angle theta. Okay, so the point PXY, where the terminal side of the angle intersects the circle, is called the terminal point. And we call this point, we denote it by P of theta, or sometimes it's also called P of t. That depends on what angle we take. We also sometimes refer to our angle theta as a real number t, and so we call that either P theta or Pt, depending on what variable you use. Okay, now, so this is also our point, let's say P theta. Then we define six trigonometric functions as follows. Okay, so the first function we define is what we call sine of theta, and sine of theta is defined as y. Second, we define cosine of theta, or cos theta, and we define that as x. So this point x is cos theta, and this point y is sine theta. So I could also write this point P theta as the point P cos theta, comma, sine theta, right? This is x, and this is y. Then we define tangent of theta, or tan theta, as y over x, or as you can see, sine theta or cosine theta. Then we have the fourth function we have is cosecant of theta, and that is 1 over y. Fifth, we have is secant of theta, which we'll define as 1 over x. And finally, we have something called the cotangent of theta, and we define that to be x over y. Now notice here, obviously, x cannot be 0. Here, y cannot be equal to 0. Right? We don't want the denominators to be 0, otherwise the functions are not defined. And so this is how we define your basic 6 trigonometric functions. We have sine theta, cosine theta, tangent theta, and then we have cosecant theta, secant theta, and cotangent theta. So note that, right, what was sine theta? Sine theta was equal to y, and we saw that cosecant theta was equal to 1 over y. So we can also say that cosecant theta is 1 over sine theta. Same way we had cos theta equals x and secant theta equals 1 over x. And so we can say that secant theta equals 1 over cos theta or cosine theta. And finally, we had tan theta equals y over x, which, by the way, can also be written as sine theta over cosine theta, right? And we had cotangent theta was x over y, which can also be written as cos theta over sine theta. So we can also, if you look at sine and cotangent, we can say that cotangent theta is 1 over tangent theta. Okay? So these are your what we call reciprocal identities or reciprocal trig functions. And we have 3 of those. So if you know sine, cosine, and tan, you can easily figure out what is cosecant, secant, and cotan.